Hello everyone, welcome to BBD. My name is Werner Mostert. I'm going to be speaking to you guys about serverless technologies. So as you can see, the topic of this talk is called State-of-the-Art Serverless. A lot of the technologies or services that we're going to be discussing today were very recently announced last year at reInvent. I'm also going to be focusing more on the non-standard kind of services that you hear about when you think serverless. So not your typical kind of API gateway with a Lambda function and a DynamoDB in the backend. It's going to be more of the kind of supporting serverless services that we're going to be discussing. So just by a show of hands, who here has actually played around with some of the serverless technology in AWS? So still relatively new to the serverless paradigm. So a lot of people are of the opinion that serverless technologies have kind of come after the containerization phase, and it's gained quite a lot of popularity, but it's still seen as a relatively new thing in the industry. If you look at the serverless platform that AWS offers you, there's a whole variety of different, how can we say, sectors that you can classify serverless services into. The first and most popular one is just the normal compute. This is where you will learn about or hear about AWS Lambda functions. So these are functions that you kind of write the code for, and you don't care about the server that it's running on. You care about the amount of memory that you give it, you care about the code that you write, and you care about the fact that it is running somewhere in the AWS cloud. Something also quite exciting, especially for us as South Africans now, is the fact that you can run a Lambda function at what AWS calls a CloudFront edge location. So these edge locations are essentially points of presence in an area within the world, not necessarily an AWS region, where you can locally run your Lambda functions. The second is what they call the API proxy. So this is essentially a way for you to accomplish an API gateway pattern using a completely managed service from AWS. It's called API Gateway. It's very scalable, very highly available, all the normal things that you would be accustomed to when writing serverless applications. Also, storage. Storage normally comes in the form of a simple storage service, or commonly known as S3. S3 is one of the most durable AWS services. I think they guarantee 99.99911 durability in their storage platform. So that means that you have a very, very small chance of losing your data. Also, data stores. These are more common for kind of application or business data. So something like your NoSQL database, which is in AWS called DynamoDB. Also things like AppSync, where you might perhaps have a mobile application that needs to real-time synchronize itself with data that exists in your backend services. Also, inter-process messaging. This comes in the form of things like a simple queuing service and simple notification service. Very highly available, also very scalable services that you can use, and also at quite cheap as well. And then lastly, the orchestration bits of it. So the orchestration part of the platform comes in the form of step functions. So what you can essentially do is you can assign these Lambda functions to run in parallel within a state machine that you specify. And you can actually track this through the AWS console, which we will do a little bit later in a nice quick demo. And then finally, the analytics part of the platform. So this is your Kinesis streams, where if you want to perhaps intercept clickstream analytics from a public website or something like that to kind of gain insight into your business. But those are kind of the mainstream ones, the things that people speak about quite often because they have a lot of business value. And as I've mentioned, I want to kind of focus on the things that are uncommon in the serverless paradigm. Or not uncommon, but just less in the highlights. So AWS X-Ray was actually announced 2 years ago in 2016 on the 1st of December. But I don't often hear people speak about it as much. So if you think about X-Ray, it's essentially what the industry calls open tracing. So it has its basis in Google's Dapper, which now these days has also evolved into products like Zipkin, for example. So open tracing, in a nutshell, is essentially a troubleshooting and debugging tool that you can use to identify very granular pieces of a specific process in order for you to say, okay, great, my API is now taking 2 seconds to respond. Which part of this process? Is it the database call? Is it the fact that the serialization is exceptionally slow? What open tracing gives you is the fact that you can, for that very specific piece of a process, identify that it's being slow. So if you go into the AWS console, this is typically something that you would see for a serverless application that's instrumented with X-Ray. So the green bits of this essentially show that all of the requests have been successful, whereas the red and the orange show that there's obviously a bit of a problem here. And you will also be able to see, as you can see here, 0.17 seconds for this specific part of the process. Another AWS service that is quite useful, and we're now going into the more machine learning kind of field of the serverless services, is something that was also announced last year at AWS reInvent called Amazon Transcribe. So this is automatic speech recognition service that you can use. A typical example is if you have a MP3 file, a music video that you want to perhaps get the song lyrics off of it with literally just having the video file there. Or if you want to perhaps caption a movie, something like that. And then also, and for me, these two kind of go very hand in hand because it's all related to speech, is AWS Comprehend. So Comprehend is not as much related to speech as much as it is related to language. This is their natural language processing service. There's essentially 4 things that you can get out of Comprehend if you give it a blob of text, or if you want to use AWS Transcribe, where you have a MP3 file, some kind of audio that you want to convert into text and then pump this into AWS Comprehend. You might be able to determine, is this song a happy song? Is this song a sad song? Etc., etc. So you get entities, things that are being mentioned, key phrases, sentiments, and also the language that is written. Another one of the more machine learning-esque services is Amazon Rekognition. So this has been around for a while. Things like object and scene detection for static images, but they also recently announced that now you can kind of analyze videos, which is pretty cool, and I'll be showing you guys a demo of this a little bit later. So Rekognition can do object and scene detection. It can detect celebrities in a crowd. It can also match your face. Interestingly enough, I don't know if any of you guys actually watched it, the royal wedding. So one of the news companies or whatever used the Amazon Rekognition service to identify celebrities in the crowd at the royal wedding. It's quite an interesting use case. Also facial analysis. So it can tell you if you're being sad, if you're being happy, how old you are as well, with surprising accuracy. Also content moderation. If you want to perhaps, I don't know, I think something like a Slack moderator where if somebody sends some explicit content, then it can be removed or kind of blurred out, for example. And also text detection from an image, specifically images. But it's very flexible in a way. So the text can be in different fonts, it can be in handwritten letters, etc. Another AWS service that's commonly associated with the serverless services is Amazon's Shield service. So this provides managed DDoS protection for you. And you can imagine how this can be very valuable to a business to ensure their business continuity. Has anyone heard about this group or recognize the symbol? Anonymous, the hacking group. They are very popular for conducting distributed denial of service attacks in order to bring down things like government websites, etc., etc. So using AWS Shield, you can prevent against something like this. So Shield comes in two flavors. The basic, that essentially protects you on a very basic level against DDoS attacks, where they monitor your network traffic to see, for example, most of the time, my website is being accessed from South Africa, but every now and again, there's an influx of traffic that comes from China. And that might be a reasonable grounds to say, okay, great, I'm not allowing this traffic through the AWS infrastructure. But if you want to level up, if you want to go to the advanced version, then you pay $3,000, which might sound like a little bit for a small business, but if you think about the kind of benefit that you get out of it, it kind of starts making sense. You have a 24/7 DDoS response team from AWS that you can contact in the case of a DDoS attack. And they actually give you insurance, where one of the ways that you can deal with a DDoS attack is by actually scaling your infrastructure up for you to be able to handle this immense amount of load. But obviously, if you scale to thousands of virtual machines, that's going to incur significant cost. So AWS with Shield Advanced will then cover you for that period of time that you had to scale up in order to provide an available service to your customers. Together with Shield, they're often mentioned together because they kind of relate to the same thing, security, is WAF. So WAF is essentially Web Application Firewall. If you look at the diagram here, it's a very common thing, especially before WAF was released, for people to construct what they called WAF sandwiches. So if you imagine your typical three-tier architecture, you might perhaps have your web servers as one cluster of virtual machines. Below that, you would have your application virtual machines where you would host your REST API or something like that. And then below that, you would have your persistence tier. So in front of all of this, before you actually get to your web application cluster, you would typically, for a large enterprise, go through a firewall. So popular products of this include something like the Fortinet firewall. And Web Application Firewall allows you to, from the AWS Marketplace, import these custom rules to prevent things like SQL injection or cross-site scripting. And then, of course, actual Amazon CloudFront. And I don't know how many of you guys know, but they launched this last week in South Africa. So we now have a point of presence in South Africa from AWS. Yay! So what does this mean for us as South Africans? That means that we have I'd like to say significantly, but it is a reduced amount of latency. It's still 14,000 kilometers that you need to get to Ireland. I tested it out a little bit earlier today. I was getting around 120 milliseconds, which is not bad considering that you're going all the way to Ireland. But this also does mean that for cacheable content, something like static files, like a website, for example, an Angular website, this means that we have a very, very small latency, which is local latency to whichever, like you would get to a typical Hetzner provided service or some of the local cloud guys. So the 120 milliseconds that I was mentioning was through the AWS CloudFront point of presence over the dark fiber and into the AWS data centers in Ireland. Okay, so with this, there's a thing called dynamic content acceleration, where if you keep a persistent connection open into the AWS data center, you essentially knock out a piece of the TCP handshake that needs to happen every time because you keep that connection open. That's how you get a little bit of a decrease in latency. And something very exciting, something very new that was also announced at reInvent is AWS Fargate. So I don't know who of you have heard of Docker containers, but this is essentially a way for you to run a container without caring on which virtual machine it is running on. So very similar to the way that you write a Lambda function, you would say, great, for this container now, instead of a function, I require at the very least 1 gigabytes of memory or 500 megabytes of memory and X amount of CPU. And AWS Fargate will take care of provisioning this container somewhere on the AWS infrastructure without you having to care about the instance type that it's running on. You don't have to care about the network topology. All that you have to care about is I have a container that's running somewhere. Okay? And what's pretty cool is currently they support native integration with Amazon ECS, which is the Amazon product for container orchestration. A similar product would be something like Kubernetes. And only last week, I think it was last week, they announced general availability for EKS, the Elastic Kubernetes Service, where Amazon now takes control in terms of a managed Kubernetes infrastructure for you, where you don't have to care about the masters. You just say, I want 20 nodes. But now, as a kind of top-up onto that, they also promised us that in 2018, sometime this year, they will announce support for Fargate with EKS. So that means that if you are familiar with something like Kubernetes, I can say, please, I want this deployment. I don't care where it's running. I just want this container to run somewhere, which is pretty powerful. And also, you don't need to care about how much you scale. The high availability and the scalability of your Docker containers will be taken care of for you by AWS. So in terms of development for serverless applications, there's quite a few very popular frameworks that are, and tools that have surfaced recently. I believe there's going to be a talk about Cloud9 just after this. I'm not going to say too much, but it's essentially an IDE for you to deploy your AWS Lambda functions on a web browser. Also, AWS SAM, the little beaver there. What SAM is all about is to give you a very opinionated and a very easy way to define serverless components like Lambda functions or DynamoDB functions without knowing all of the complexities of AWS CloudFormation, which is the infrastructure as code service from AWS. What this allows you to do is you write a very small specification file, and it will then transpile this into CloudFormation templates for you that you can just deploy. Also, CloudFormation, as I just mentioned, is the infrastructure as code thing or service that you have to get acquainted with if you want to effectively deploy AWS infrastructure. Also, from the company called Serverless, there's the Serverless framework, which has gained quite a bit of popularity these days, but this is not specifically focused towards AWS. This is a cloud agnostic, so all of your big ones like Azure or Google Cloud, they all support that, and it's also just an easy way for you to manage your development time with serverless applications. So as I've promised, I'm going to show you guys a little bit of a demo now of a serverless application that we're going to deploy. So if you look at this architectural diagram here, these are all the serverless components that make up this system. So just to give you some background, the media analysis serverless solution is a sample solution from AWS where you kind of, to showcase their AWS capabilities or their serverless capabilities. It's a website, so it uses an Amazon S3 bucket to host static content. We use your typical AWS Lambda with Amazon API Gateway to form your kind of logic layer for this application. For security, I didn't mention this now, but they use Amazon Cognito, which is an easy way for you to bring authorization and authentication into your web and mobile applications. Also, together with that, AWS Step Functions, where we're going to upload a video or an MP3 file or a picture of something of the sorts into an Amazon S3 bucket. This bucket will then, via an event, notify Lambda functions that will execute in parallel with this step function and use Amazon Comprehend to try and understand what this video or audio is about, use Transcribe to caption it, and use Rekognition to do video tracking as well as kind of facial analysis of the people in it. Finally, once we have all of this information, we'll put that into an Elasticsearch cluster, which we can then query to find whatever it is that we're interested in. So let's get started. So as I've mentioned, this is a sample solution from AWS. And to give you an idea of how easy it is to deploy it, you click on Launch Solution. This will by default take you into North Virginia, which is fine for now. It already references the Amazon S3 bucket, where this CloudFormation template is in. And it's going to ask you for your email address. So I will put mine in there. Next, I'm going to tag this like a proper Amazonian and say AWS User Group. Right. All of the defaults here are fine. And I click Create. What this will now do is it will create a new stack for us, where it's going to provision each and every one of those components that we just spoke about. And then finally, it will send you an email with your login credentials as well as the place to access it. So because of our time limitations here, I've already created this stack in a different region, Ireland. Just a word of warning, not all of these services are available in all of the AWS regions. I know that they are available in Ireland and at least North Virginia. There's a place where you can check it, but just make sure before you deploy it. So what you can see happens is this media analysis solution essentially creates 3 individual nested CloudFormation stacks for you, where the one is responsible for storage bits of it, so the S3 buckets, the API stack, which would be your Lambda functions and your API gateway, as well as your state machine, which would be the machine learning bits of it, together with the step functions. So let me give you guys an example of the step functions that we ran. So this is what a typical state machine would look like. It's a little bit small now. But you can see that this part over here is essentially where the parallel machine learning takes place, using the Transcribe, Comprehend, and Rekognition services. And then finally, it sends you an email with this link to access it. So I'm just going to log in using Amazon Cognito. And I've already actually uploaded a video onto this stack. And you can see that this is the Portugal versus Spain snippet highlights from Friday. If I click on View Results, I can now start playing this. Just want to put the volume up. And if I am interested in celebrities in here, I can choose Cristiano Ronaldo. You can see that it is now tracking Ronaldo on the video as it's going.
Cristiano Ronaldo. He's the only Portuguese player to score.
And if I click on something like persons, I can track each and every individual player that's on the field. And you can imagine using this kind of information, you can do stuff like predictive analytics on who's going to win the game or how they played, etc.
Long ball forward, looking for Diego.
Quite interesting. We're using Amazon Transcribe. I can hear how the commentator kind of says stuff.
And goes down, play continues, it's Diego.
To add dynamic subtitles onto this video. So if you wanted to take this a little bit further, you can actually analyze with Amazon Comprehend the actual captions that are on there. So if you look at something like this, it can show you entities. It sometimes gets a little bit wrong where it says Cristiano instead of Ronaldo, and 1-0 Portugal, stuff like that. Also facial attributes. So if I wanted to say where are all the males in this video.
Great dash, onside. Ronaldo wasn't initially. Ronaldo with the
obviously no males yet. Oh, Ronaldo's a male.
Portugal's second goal of the night, his second goal of the night, and very much against the run of play.
Faces. If I wanted to go back a little bit, I think you guys get it now, and go to upload. I can upload almost any type of media onto this. I can upload audio, I can upload a video. I can also, for my collection, upload a picture of myself. So I couldn't find a video of where I myself am walking between people or whatever. But if you uploaded your face on here, you could track your face the same way that we tracked Ronaldo just now. And yeah, that's just to give you guys an idea of what it is that you can accomplish with serverless technology. None of this, not a single one of this, is on a virtual machine that we have to care about ourselves. Great, that's my time. Thanks, everyone.